Hi everyone, I'm Crystal, a volunteer with Let's Talk Science at the University of Victoria. Have you ever seen a small bug walk on water? Well, I have, and I found it really interesting. This is because of surface tension. And surface tension is simply the force within liquids like water that causes it to hold itself together. So for today, we are going to look at surface tension using these materials. You will need a plate, a glass filled with water, and some coins. First, I'm going to put the glass on the plate gently. If you look really closely, you will see how the water at the top is a little bit curved. Next, I'm going to test the surface tension of the water in this glass. How many coins do you think I can put in? Let's see. First, 1, 2, 3, 4, 5. The water is shaking, but the surface tension is still holding it together. 6, 7, 8, 9. If you get really close, you can see the water is curving at the top. And 10. Wow. So the surface tension of the water in this glass allowed for 10 coins to go inside without breaking the tension. I wonder, if I had more coins, do you think it would break? How about trying it at home with your parents and your siblings? Thank you.
Hi, my name is Hannah and I'm a volunteer with Let's Talk Science at the University of Victoria. Today I'm going to show you some magic, also known as science, that we can do with milk. If you want to follow along, here are the things you'll need. You'll need about half a cup of milk. Skim milk does not work very well, so try to find milk with a higher fat content, like 2%. You'll need a few colors of food coloring. You will need a couple drops of dish soap, a Q-tip, and a bowl or a pie pan or a deep plate, something that you can pour the milk into. Don't forget to ask an adult for permission, especially before you use up something like milk. The first step is to pour the milk into the bowl. It doesn't have to be very deep at all, but make sure it covers the bottom. Next, put 1 drop of each color of food coloring near the center of the bowl. The blue came out way too fast when I was filming this video, but I didn't want to waste the milk by starting over again. Dip one end of your Q-tip into the dish soap and hold it above the bowl. Finally, dip the soapy end of the Q-tip into the milk right in the middle of your dots of color. Look at that! If you leave the soapy Q-tip in the milk for a few seconds, you might see some other patterns start to emerge. This explosion of color happens because there are a few different types of molecules involved. If a molecule is attracted to water, we call it hydrophilic, and if it is repelled by water, we call it hydrophobic. Soap is special because it's both. One end of the soap molecule is hydrophilic, and the other one is hydrophobic. All of this movement happens because the molecules are trying to match up with other molecules of the same type. The hydrophobic ends of the soap molecules move around because they are attracted to fat particles, and when they reach a fat particle, they huddle around it so that they can escape all the water that's around them in the milk. If you give your bowl a little swirl, you might be able to make even more beautiful patterns. But if you mix it up too much, it might become a brown sludgy potion. Simone is going to talk to us about potions next, but this part of the video uses some materials that can be dangerous, so you should not try this at home.
I thought this year for Halloween I'd mix up a potion. What's the secret ingredient, you ask? Dry ice. Dry ice is solid carbon dioxide, and what you can see when I add warm water to my cauldron is the dry ice undergoing a phase change. We're used to seeing phase changes like freezing, when something goes from a liquid to a solid, but dry ice undergoes a little bit of a special one. At room temperature, carbon dioxide is normally a gas, so when I take dry ice out of the extra cold freezer where we store it, it starts to become a gas again. The phase change directly from solid to gas is called sublimation. We don't see this one so often. Adding warm water to dry ice speeds up this process, making more CO2 gas at once. The cloud you can see coming out of my pumpkin is made up of tiny droplets of water trapped in the gas, similar to the clouds you see in the sky. Happy Halloween!